This is Section 7.7 Notes Day 1. Today we're going to talk about exponential growth. Exponential growth is an equation that has an exponent in it, and from the graph you'll see that it starts down by 0 and it gets larger, so it goes up positive. It can also start near 0 and go negative. So that is also exponential growth, starting near 0 and either going up to positives or down through negatives. Now, a couple examples here are y equals 3 times 2 to the x power, or y equals 1/2 times 4 to the x power, or y equals 7 to the x power, y equals 0.2 times 3.2 to the x power. You'll notice that all of these numbers, all the base numbers with the exponent, are bigger than 1. So that takes us to the next page. The equation will always look the same. You'll always have y equals times an initial amount, that's whenever x is 0, times the base number, which has to be greater than 0. That's what we call the growth factor. And then it's always to the x exponent. So using this equation, we can do a number of different problems. So problem number 1 says write an exponential growth equation to model the number of students enrolled at a college is 15,000. So that's their starting amount. And it grows 4% each year. So step 1 is to find the initial amount, the starting amount. So this college starts with 15,000 students every year. Step 2 is what is the growth factor as a decimal. So the growth factor, it's growing at 4%. So I have to convert 4% to a decimal. So what I do is I move the decimal over 2 places. So this will be 0.04 as a decimal. Step 3, since the growth factor must be larger than 1, 0.04 is not bigger than 1 at this point. We need to then add this decimal to 1. So I'm going to take 1 plus 0.04. That ensures that my growth is going to be bigger than 1. So now it's 1.04, which is greater than 1. Now I just write out the equation. So start with y equals, and it goes in order, the initial amount, 15,000, times the growth factor, 1.04, to the x power. That is the equation. Then it's asking, how many students will be enrolled after 35 years? This is going to be the exponent. So I'm going to plug that in for the x. So I'll have y equals 15,000 times 1.04 to the 35th power. Now using my calculator, I can plug that all in, and I get 59,191.33. Now I'm talking about students, I'm talking about people. Can I have 0.33 of a student? No. So what you're going to do is you're going to round this up. So you're going to have 59,192 students. And that is how many students this college will have after 35 years. Okay, so the next problem is just identifying. So they give you the equations this time, and they want you to identify the initial amount, which is going to be called A, and the growth factor, which is B, in each exponential function. So for here, I have g of x, which is the same thing as y equals. The first number here is going to be A, and the second number is going to be B. So A, the initial amount, is 14, so it starts at 14. And B is the growth factor, which is 2. Okay, it has the exponent on it, so that's how I know it's the growth factor. And then I'm done with this problem. I have the initial amount and the growth factor. This next one, my initial amount is 150. My growth factor is 1.01. Letter C, it's a little bit tricky. My initial amount is the number that doesn't have the exponent. So the 1.4 is the growth factor. the imaginary number that's out in front here that's being multiplied is a 1. So your initial amount here is 1. So your initial amount is 1, and your growth factor is 1.4. So whenever you just have a growth factor with an exponent, your initial amount will always be 1. So using an exponential growth function, we can do compound interest. So this is the type of interest that your banks and almost all financial institutions use to calculate interest, or to calculate how much money you should have in the bank or in your accounts. So it's a really long formula. It starts with A, that's the amount, equals P, that's the principal, parentheses 1 plus, because it's going to grow, so it's a growth, R, which is the rate, divided by N, that's the number of times it's going to be compounded, all to the NT exponent. So N is the number of times it's going to be compounded per year, and T is the time in years. So we're going to talk about problem number 2, and we're going to label as we go along all of these variables. Okay? So when you were born, your parents deposited $2,000 into an account. $2,000 is the initial deposit. So if I go up here, the initial deposit is going to be called the principal, so that's going to be my capital P. It's paying 4.5%. That is the annual interest rate, but I need to express it as a decimal. So I'm going to take 4.5%, and I have to move the decimal over to the left 2 times. So this will really be 0.045, and that's the rate, or R. And that's interest compounded quarterly. Quarterly is 4 times a year. That's the number of times the interest is compounded per year, so that is the N, the number of times. What will the account balance be after 18 years? That's the time in years, so this is T. So P is 2,000, R is 0.045, N is 4, and 18 is T. So now I'm just going to plug all these numbers into the formula. A equals P. P is 2,000, parentheses, 1 plus R, which is 0.045, divided by N, which is 4, and my parentheses, and my exponent is going to be 4 times 18. Okay, so simplifying this down, I'm going to do my parentheses first. So I will have 2,000 times 1 plus 0.045 divided by 4 is going to give me 1.01125. I just used my calculator to calculate that. And that's still to the 4 times 18th power. Next, I need to do the exponent. So I have to simplify my exponent. 4 times 18. So I'll still have 2,000, and I'll still have 1.01125. And 4 times 18 is 72. So once I'm simplified this far, I can actually use my calculator and plug this in. So 2,000, parentheses 1.01125, and the parentheses in the calculator. Use the little caret key, which looks like this on your calculator, to calculate it. And you'll get the amount in your bank account after 18 years will be $4,475.53. Go ahead and pause the video, get out a calculator, and try to plug this in and verify that you get the same number in your calculator. We're just checking to make sure that you are plugging it in correctly.